Welcome to the next session of traveling wave tube amplifier, which is called as wave modes of traveling wave tube amplifier. Okay, so in the previous class we had discussed the axial current, axial electric field as well as the conversion current based upon the equation that is been obtained in conversion current and axial electric field. We will try to derive the expression for wave, or we will try to see the different modes of operation of traveling wave tube amplifier. Okay, so let me proceed from here. The first point, the wave modes of helix travel wave tube amplifier can be determined, as I told you, by solving the electronic and circuit conversion current according to circuit equations simultaneously for the propagation constant. Okay. So for the what you call as the solution of the propagation constant, that will represent a modes of different modes of traveling wave in the tube. Okay. So we can proceed with that one. The wave mode of helix traveling wave tube, can be determined by solving the what I call as the electronic and circuit equations. Okay, equations simultaneously. Okay, simultaneously for the propagation constant. For the propagation constant. Okay, so each solution of the propagation constant, as I told you, each solution of the propagation constant represent a mode of traveling wave, represent a mode of traveling wave in the tube. Okay, so I will take the equation for conversion current. Equation for conversion current, conventional current, and that is nothing but I. It's not I, and axial electric field, that is nothing but E1 or Ez. Okay, are that there are four distinct solution. There are four distinct solution for the propagation constant. For the propagation constant, that is, there are four modes of traveling wave tube, four modes of traveling wave tube in the O type, traveling wave tube amplifier, in the O type traveling wave tube amplifier. Okay, So I will take the equation for the conversional current, that is I is nothing but J beta E I naught E1 divided by 2 V naught J beta E minus gamma the whole square. So this can be, this E1 can be either Ez also, okay, no problem. Call it as equation number 1. And I will write that, and E1 can be equal to Ez, and that Ez is given by minus gamma square gamma naught Z naught I divided by gamma square minus gamma naught square, called as equation number 2. Okay, so substitute equation 1 in equation 2. You substitute equation 1 in equation 2, what you will get, that you have to see. That is E1 is nothing but minus gamma square gamma naught Z naught J beta E I naught E1 E1 divided by 2 V naught J beta E minus gamma the whole square. This is something E1 is not, divided by what, gamma square minus gamma naught square. Okay, so what I will do, so this E1 get cancelled, so ultimately you have gamma square minus gamma naught square is nothing into this term also. Okay, I will bring this term J, this term into J beta E minus gamma the whole square is nothing but minus gamma square gamma naught Z naught J beta E I naught divided by 2 into V naught. Okay, so to find the appropriate solution, you just put gamma naught equal to J into beta E, right? To find appropriate solution, put gamma naught is equal to J into beta I. Okay, so this equation will be the fourth order. So after putting this one, you will get an equation that it will be in the fourth order. Okay, is the fourth order in gamma and has 4 modes. Okay, so its exact solution can be obtained by numerical method, can be obtained with the numerical method. Okay, so the first point, second point, third point, next point is nothing but the solution can be found by equating the electron beam whose actual phase velocity of traveling wave. Okay, the solution may be found by equating DC electron beam whose actual phase velocity of who use actual phase velocity of traveling wave, that is putting gamma naught is nothing but j into beta e. Okay. So I will put gamma naught is nothing but j in this. Here I will put gamma naught is equal to j into beta I. Here also I will put gamma naught is equal to j into beta I. Okay, okay. Then we can see that one. So put in that one, gamma square minus j beta I square. That's the one first term. J beta I minus gamma the whole square will be equal to minus j beta I naught gamma square j beta I z naught divided by 2 into v naught. Okay. So what I will do is I will just this I can expand it, that is gamma minus j into beta I into gamma plus j into beta I into 1 minute. This term is nothing but j beta I minus gamma. It's not j beta I minus gamma only. But I can do that. 1 minute. J square will be minus 1. 1 minute. Small change. J into beta I minus gamma. J into beta I minus gamma. Just I see j into beta I minus gamma. Same thing all getting, because j into beta is minus gamma. So I will just rearrange this one, this term, that is gamma. I will take this as gamma minus j into beta I the whole square. Okay. So if I take minus 1 minus gamma plus j into beta I the whole square. Okay. So I will take that one minus j square will be so this j is nothing but j square, so that will be minus 1, so it will be what called as I naught z naught by 2 v naught into I naught z naught by 2 v naught into gamma square beta and beta is will be beta I square. Okay, beta I square. I have rearranged. I have changed this is as because this will be like this, j beta a square minus 2ab plus b square. Okay, j square is nothing but minus beta square, j is nothing but minus 2j beta I plus gamma square. Okay, so even if I take this one, this will be gamma square, that is gamma minus, if I expand gamma minus j beta I the whole square, what I will get, this will be a square minus 2, this will 2 gamma is also the 2 j beta I gamma minus j beta I the whole square, so that will be gamma square minus 2 j beta I gamma, j square is nothing but minus 1, so this term will be plus j beta I square, it's not minus j beta I, it will be gamma square, we are getting the correct things, 2 j beta I, j square is nothing but minus 1. So a small change only. Okay, this term, that is the beta I square terms is being changed. Anyway, we are rearranging this one. Okay, no problem for that one. Anyway, 1 minute. If is the range. j square minus 1. 1 minute, just I will see, just I will. So the same thing only we will get, because no correction, because minus of j square is nothing but minus 1 into beta square. This will be plus, okay. Okay, anyway, leave it. I will take like that only. So this becomes a gamma minus j beta e into this one called as cube into gamma plus j beta e, okay, will be equal to I naught z naught divided by 2 v naught gamma square beta e square, okay. So that I will call it as, let c equal to I naught z naught divided by 4 v naught whole raised to 1 by 3, okay, gamma square b. So this is nothing but the c, I can call it as gain parameter of travel wave 2. So what I will do, substitute, that is equation 1. Now what is that equation 1? Equation 1, somewhere it is here. Equation 1, I put what I have put, I naught z naught by 4 v naught, I naught what is the equation? I take this equation also, it's not, I will call this as equation 1 minute, j beta anyway, correct only. So this equation changes to gamma minus j beta e the whole cube into gamma plus j beta e is nothing but this I can write, because 2 c cube in the sense means this will be I naught z naught divided by 4 v naught. So 4 v naught means 2 and 4 will cancel, it will be like this, that is 2 into c is nothing but I naught z naught divided by 4 v naught whole cube means 3 and 3 can cancel, so this will be cancelled, you will get the same answer. So correct. So c cube beta e square gamma square, what is this equation number? Here somewhere I have put equation number, you leave with this equation, I just put this equation as 2, anyway I will put this equation as 3. 1 minute, call this equation number 3, okay. Let gamma equal to j beta e minus beta e c into delta, that I will call it as propagation constant of what you call it as 1 minute, just I will see. They have taken propagation constant, okay, say right, same only, propagation constant of 3 forward traveling wave, forward traveling wave. Okay. Gamma plus j beta. Okay, some slight changes. Okay. So I will take also I will take c into delta is very much less than 1. Okay. So substitute uh, substitute what gamma in equation 3. Okay, substitute gamma in equation 3. What you will get? Gamma is nothing but j beta e minus somewhere j beta e minus uh, beta e c delta minus j beta e the whole cube into j beta e minus beta e c delta plus j beta e, which is nothing but 2 c cube beta e square j beta e minus beta e c delta the whole square. Okay, so what I will do, this and this can cancel. So ultimately it changes to minus beta e c delta the whole cube. This will be j beta 2 j beta e minus beta e c delta, which is nothing but 2 c cube beta e square. This I will change it as a minus b the whole square. A minus b the whole square is equal to a square, that is j beta e the whole square minus 2 j beta e c delta plus beta e c delta the whole square. Okay, so this will be minus beta e c delta the whole square into 2j beta e minus beta e into c into delta, which is equal to 2 c cube beta e square. A square is nothing minus beta e square minus 2j beta e square c delta plus beta e square c square delta square. Okay, so this will be, this is cube, this will be, I will take from here I will take beta e outside minus beta, from here this term I will take beta e, from this term I will take beta e outside. So beta e into beta e, beta raised to 4 okay, into c cube delta cube, then the left term is 2j minus c into delta, which is nothing but 2 c cube, here also beta e I will take outside, beta raised to, this is nothing but beta square, here I can take beta square, each term here I have beta square, so it will be beta raised to 4 into minus 1 minus 2j c into delta plus c square delta square. Okay, call this equation number 4. So this term get cancelled, this term get cancelled, and also since c into delta is very much less than 1, you neglect c delta terms. Okay, you neglect c delta terms. So what you will get? Minus delta cube 2j equal to, here C delta terms will be gone, equal to minus 1. So minus 1, again one more term is there, 2 into this term, 2 into 2 also there, 2. Okay, so these two get cancelled, minus and minus will go, so minus delta cube j equal to minus 1, which implies delta cube into j equal to 1. That implies delta cube is equal to 1 by j, which is like minus j. Okay, so delta will be minus j raised to 1 by 3. Is it clear? So we can write delta is nothing but in this form, that is e raised to minus j into pi by 2 plus 2n pi by 3. Okay, I'll just verify that one. Yeah, 2n pi by 3. So where n equal to 0, 1, 2, etc. Okay, so here pi by 2 is nothing but a phase shift. Pi by 2 is nothing but phase shift done by punching of electron, and roots of delta 1 comma delta 2 and delta 3 we have to find it. So you have to find the root of delta 1 at n equal to 0, that is given by delta 1 is nothing but e raised to minus j pi by 6, which is nothing but root 3 by 2. I think root 3 by 2 minus j 1 by 2. I will write here cos theta minus j, this is in this form, cos theta minus j sin theta is equal to e raised to minus j theta. Okay, cos theta minus j sin theta is equal to e raised to minus j theta. Keep in mind this one, because you can see that delta is e raised to j theta, theta is nothing but pi by 2 plus 2 pi by n, 2n pi by 3. So it's of this form, cos theta minus j sin theta. Okay, so this is the first root. Similarly, the second, that is delta 1 delta 2 at n equal to 1. So delta 2 will be e raised to minus j 5 pi by 6, which is nothing but minus root 3 by 2 minus j into 1 by 2, because e raised to j theta is equal to cos theta plus j sin theta. Theta is nothing but for this term cos of j minus j pi by 6 minus j sin theta is nothing but theta is nothing but pi by 6. Okay, it is only pi by 6, like that we will get pi by 6 minus j pi by 6. So that term is nothing but root 3 by 2 minus j. Here cos 5 pi by 6 minus j sin 5 pi by 6, like that you will get root 3 by 2 minus j into 1 by 2, that is delta 2 at n equal to 1. Similarly, what you will get, delta 3 at n equal to 2, that will be delta 3 will be e raised to minus j 3 pi by 2, that is, I think it is j nearly. Let me see that one. Yeah, and the fourth root fourth root corresponds to the backward traveling wave. Okay, and this can be obtained by setting delta equal to j beta minus beta I c into delta 4. Stop. Sorry, gamma equal to, by setting gamma equal to j beta I, I think it is minus j. Gamma, what is gamma? Minus j beta I minus beta I into delta, that is minus j beta I minus beta I c into delta. That is similarly you will get what you called as delta 4. Similarly, delta 4 will be minus j c square by 4. Minus j c square by 4, like that, because in delta 4 what I had take gamma. Okay, so the fourth root corresponds to the backward traveling wave, and this can be obtained by setting gamma equal to j beta I minus beta I c into delta 4. Beta I minus c into delta 4. Okay, so from here delta 4 can be written as minus j c square by 4. Okay, thus the your values of 4 propagation constant are given by, so you note that you take one note in gamma is equal to j beta I minus beta I c into delta, the values of delta 1 comma delta 2 comma delta 3 are substituted to get gamma 1 comma gamma 2 and gamma 3. Okay, in gamma equal to j beta 1 beta I j beta I minus beta I c delta, the values of delta 1 delta 2 delta 3 are substituted to get gamma 1 gamma 2 gamma 3. Okay, and we will get gamma 1 is nothing but j beta I minus beta E c into root 3 by 2 minus j into 1 by 2, which is nothing but minus beta E c into root 3 by 2 plus j beta I into 1 plus c by 2. Okay, similarly gamma 2 is nothing but j beta E minus beta I c into minus root 3 by 2 minus j into 1 by 2. So that changes to beta E c into root 3 by 2 plus j beta E into 1 plus c by 2. Okay, next gamma 3 is nothing but j beta E minus beta I c into j, that changes to j beta into 1 minus c. Okay, and and one more thing is that, and you take what otherwise, one minute, and in gamma 4 equal to, and gamma 4 equal to minus j beta e minus beta e c into delta 4. So delta 4 value is substituted here. So you have gamma 4 is nothing but minus j beta e minus beta e c into minus j into c square by 4. Yes, no, gamma 4, yeah, j into c square by 4. So what you will get? Gamma 4 is nothing but minus j beta e into 1 minus c cube by 4. Okay, these are the 4 propagation constant. Okay, the 4 propagation constant, one minute, I'll just take that one. The 4 propagation constant represent 4 different modes of wave propagation. 4 different modes of wave propagation in the O type, helix, traveling wave tube. Okay, so we can see the conclusion part of this one. Can see the conclusion. Okay, so it is concluded that the wave corresponding to gamma 1 is a forward wave. Okay, and that its amplitude grows exponentially with the distance. Okay, that is the first point. The second one, wave corresponding to gamma 2 is also a forward wave, but its amplitude decays exponentially. With the distance. The third point, gamma 3 is also a forward wave, but its amplitude remains constant. Okay, the fourth wave, corresponding to gamma 4 corresponds to gamma 4 is a backward wave. And there is no change in amplitude. Okay. So I will write the next point. The growing wave propagate at a distance at a phase velocity slightly lower than the electron beam velocity, slightly lower than the electron velocity. Okay. One minute, I will just see. Okay. Slightly lower than the electron beam velocity. Electron, I'll put it as beam velocity. Okay, and the energy, this is the same thing what we have discussed in the initial condition why I explained something regarding the traveling wave tube. Okay, and the energy flow from the electron beam to the wave. Okay. Next point is the decaying wave propagate at the same velocity as the growing wave, but the energy flow from the wave to electron beam. Okay. Next point is the constant the constant amplitude wave travels at a velocity slightly higher than the electron beam velocity, but no net energy exchange occurs between the wave and the electron beam, between the wave and the electron beam. Okay, and the last one is the backward wave progress in the z direction with a velocity slightly higher than the velocity of the electron beam on as much as 1 minute. uh, electron beam on as much as the what you call as our typical value of C, as much as the typical value of C, which is about the value of C is about 0.02. Okay, so these are the something regarding the what you call as different modes of operation of what you call as our uh, or the different propagation constant, and each propagation constant constitute the different waves that is being moving. Okay, forward wave as well as the backward wave. I think it has been clear for you. We can see the gain consideration as well as the some one problem related to this traveling wave tube in the next video lecture. Thank you.